Okay. This example is about employee scheduling. This is a business. It wants to run this business with the fewest number of employees. And there are some limitations. Each employee must work 5 days in a row and then take 2 days off. So employees who start their job from Monday, they must work Monday to Sunday. Employees who start their work from Monday, they must work 5 days, Monday to Friday, and then take 2 days off. For those who start their work on Tuesday, they work until Sunday and then take 2 days off, Sunday and Monday. That's the only constraint of this example. The other constraint, the number of employees must be integer. It makes no sense to get real numbers for the number of employees. These are two constraints of this model. An objective is to find fewest number of employees. This is going to be our objective. Constraint, objective, and decision variable. How to put employees in different days. Number of employees start their work on Monday, Wednesday, Thursday, and etc. So this is going to be our decision variable, and we put some trial values here, and there is the constraint, employees available must be bigger than or equal to the employees required, and total number of employees. We want to minimize this one. So first, read the example. Make sure to bring your textbooks here, because in this chapter 14, 15, and 16, you have to work on different type of examples. All right, let me read it for you. A small business requires different number of full-time employees on different days of the week. The number of full-time employees required each day is given in table 14.1, this table. These are the minimum number of employees required for each day. Okay? So first we have to read this line by line and then interpret it to find different type of variables, decision, objective, constraint, and etc. Company state that each full-time employee must work 5 consecutive days and then receive 2 days off. For example, an employee who works Monday through Friday must be off on Saturday and Sunday, as I just mentioned. The company wants to meet its daily requirement, wants to meet these requirements using only full-time employees. Its objective is to minimize the number of full-time employees. So the number of full-time employees is going to be our objective variable. Okay. Now let's go to next page. So this one is going to be our decision variable. We want to determine how many employees to put on Monday through Sunday to be able to minimize the total number of employees. So first, we have to define a range for this, name for this range. So first we need to highlight it and go to Formula, Name Manager, and we define a name for this range because we are going to use this range as our decision variable. Name, it refers to model B4 to B10, this one, Monday through Sunday, and we call it employees starting. Employee underline starting. It means those employees who start their work, for example, Monday, Tuesday, Wednesday, on different days of the week. Okay. So this is going to be our first name, employee starting. So employee starting is the decision variable. Total employees, this cell is going to be our objective variable. So we select these two and then create from selection. Left column is going to be the name of this variable. Click OK, and you can check the defined variables from this menu, Name Manager. Total employees and employee starting. There is another variable. Our constraint is that employees available must be bigger than or equal to the employees required, because we want to meet this constraint. Any questions? Any issues? Okay. So for this constraints, we select employees available, this row, and then define a name for this range. It's much easier to use name instead of just defining the reference to that cell. Employees available, and then create from selection. And the other variable is the employees required. We will do the same. Highlight these cells, create from selection. Left column is going to be the name of this variable. If you click on Name Manager, you will see the list of variables defined for this model. Employees starting refers to model B4 to B10. Employees available refers to B23 to H23. Employees required and total employees. Okay. Now we have defined our variables. Now we want to define, develop our model. For this first part, a person who starts its work from Monday must work from Monday through, must work for 5 days and then take 2 days off. So For this decision variable, we need to enter some trial values. Later, Excel or Solver will change these values. For example, 1, 2, 3, 4, 5, 6, and 7. You can just only enter trial values for the decision variable. We have already defined this range as our decision variable. We want to see how many employees start their work on Monday. This one equals B4. Number of employees who start their work on Monday, B4. And then we need to copy this formula from Monday through Friday. Because according to the example, an employee must work 5 days in a row and then take 2 days off. Now for Tuesday, we start from here. Equals B5. Sorry, B5. 2 employees start their work on Tuesday. They work from Tuesday to Saturday and then take Sunday and Monday off. The same for Wednesday, equals B6. And then copy it across the cells to Sunday. 1, 2, 3, 4, 5. Yeah. Thursday, number of employees that start their work on Thursday is 4 or B7. Equals B7. And then we copy it to the end of the column, and we have to copy it all in Monday. So if an employee starts his work on Thursday, he must work Thursday through Sunday and Monday, and these 2 days are off. For Friday, B8. 5 employees start their work on Friday, and then copy to these cells. For Saturday, that equals B9. We copy into Sunday, Monday, Tuesday, and Wednesday. For Sunday equals B10, and then we copy it Monday, Tuesday, Wednesday, Thursday. Okay. Here's a list of employees, number of employees who work on different days of the week. For example, for Monday, we have a total of some B14 to B20. We have 23 employees on Monday. Does that make sense? If you have any questions, let me know. No? Okay. And then we copy this formula to the end, to the last cell. Summation of employees in different days. For example, on Tuesday we have 21 employees. You already know the number of employees required on for different days from this formula, from this cell, and total employees is the summation of these decision variables, these decision cells. Employees starting. So we want to minimize these total employees. Now we have connected our decision variable to the objective variable, and we know our constraints. Employees available must be bigger than or equal to the employees required. And now we want to determine the optimal values for this decision variable. We need to click on Data and then select Solver. Here in this cell, we need to define our objective variable. Objective is the total. We define it as total underline employees. And our objective is to minimize the total employees. So we need to select min or minimize. For the decision variable, it's going to be employees starting. And here in this box, we will define our constraints. What's our constraint in this model? What do you guys think about the constraint? Which one is our constraint? The employee required. Employees available must be bigger than the employees required. We must meet this constraint. So here, employees available must be bigger than or equal to the employees required. Employees underline available must be bigger than or equal to the employees underline required. Click Add. We have another constraint. Our number of employees must be integer. For example, we cannot get floating point like 1.9 employees, make no sense. So it has to be an integer, 1, 2, 3, and etc. So the other constraint is that this variable, decision variable, employees starting, it must be integer. From this drop down box, you need to choose int. Okay, I misspelled something. Employee starting. Now click add. Here's the model. Total employees, the objective variable. Employees starting their job. Their work is the decision variable, and we have two constraints. Employees available must be bigger than the employees required. And the number of employees must be integer. And again, we select this one for non-negativity constraint. And from this drop-down box, we use simplex linear programming. And let's see what we get as a result. Okay. These are the optimal values for the decision variable. And the minimum number of employees is going to be 23. That's how we can manage employees for different days of the week. 6, 3, 3, 7, 3, and the total number of employees is going to be 23. You see that this model meets the constraint. Employees are available on different days of the week, bigger than the employees required, and the optimal value or the minimum value is 23. Does that make sense? If something is not clear, please let me know. Please make sure to install Decision Tool Suite on your machines, because you will have to use these packages like Risk, Stat Tools for the rest of the semester. And if you have any problems, please let me know or contact that guy, Robin Holloway from Palisade. And I think they've already activated this license. That shouldn't be a problem. All right, that's all for today. Thank you very much.